Alrighty, we are on day 6. Day 6. This isn't a difficult topic, although some kids kind of struggle with it. So let's take a look and see what we got here. What we have here is a parabola. Now, the important part of this parabola is right here at the end, this part right here. It means less than 0, Mr. Krause, but what does that mean? It means negative. Now, what I want to do is show you what this looks like graphically. So we're going to go take a look at this graphically. And so it's x squared. So x squared plus 5x plus 6. Not 66 plus 6. Hopefully I did this correctly. Enter. Ooh. So this says, where is this negative? So if you look in this area, maybe I can zoom in a little bit. Let's see if I can zoom in. Menu, zoom. Let's just zoom in right there. Zoom in. Okay, so what you want to look at is, what happened? Okay, let's go back. Okay, so where is this negative? So it's positive, meaning above the x-axis here. And then all of a sudden, about right there, it cuts down and goes below the x-axis and above the x-axis. So if I just put on a trace, graph trace, and I go to the, let's go to the left. Okay, so it's over here. Now notice what the y values are. The y values are positive. If I keep going this way, the y values keep getting more and more positive. All right, so then as I move to the left, the y value is getting smaller and smaller. And eventually, more problems with the pen, kids. You know, got to have problems with the pen. There it is. It's equal to 0. Now, where is it equal to 0 at? It looks like at negative. That's the vertex. I don't know why that's there. Menu, trace, graph trace. So it looks like it's at 0 at negative 3, 0. So at negative 3, 0, that looks like a breaking point. And now the y values are all negative. Y values are all negative, until I get to negative 2, 0. And there's another breaking point. And then we go to the right, and all of a sudden they become positive. So we call these points where it crosses from the bottom to the top, we call them critical numbers. I call them critical numbers. Those are the numbers where you want to start testing at. So how do I get those? Well, I think it should be obvious. We're going to factor. And this one gives me x plus 3, x plus 2. So my two roots are x equals negative 2 and x equals negative 3. This should have been negative 3. Negative 3 and negative 2. So those are my two critical numbers. Those are my two testing points, negative 3 and negative 2. I want to know where it is negative, where it is below the x-axis. Well, I already showed you it's in between these two, but I need to be able to test this algebraically. So I'm going to pick a number. First of all, because it's less than, I'm going to put open circles right here. I'm going to be careful with that. That's not always true. So I have to decide, am I going out or what happened, kids? Somehow my drawing ended up, I don't know how that happened. Well, anyway, sorry. Oh, my drawing ended up weird. So, or, and these are open circles, or am I going to connect the dots? I got to decide that. So I got to be able to do it algebraically. First of all, I know they're open circles because it's less than. So what I want to do then is I want to pick numbers. So I'm going to come over here. I'm going to pick 0. I'm going to pick negative 2.5. And I'm going to pick negative 10. Just numbers that are easy to plug in. So let's plug in negative 10 in here for x. Now the only thing we're concerned about is negative or positive. So negative 10 in for x. If I add those up, doesn't that equal negative 13? Again, I only care about negative, so it's negative and negative. What is a negative times a negative? It's positive. So in this area, down off into this region, it's positive. For this one here, x is negative. Now let's try 0. If I plug in 0, I get positive 3 and positive 2. Positive 3 times positive 2 is, I don't care, it's just positive. So now I got to check in between. Let's try negative 2.5. If I plug in negative 2.5 to this one, that's 0.5. If I plug in negative 2.5 into this one, this would be negative. So this is positive times negative, and this area would be the area where it's negative. Well, I want negative, so I want to connect the dots. And so my answer is negative 3, 2. Now let's try absolute values. What I want to do is I'll set this equal to 0, so x minus 3 greater than 4, and x minus 3 less than negative 4. I still need to find my critical numbers. Now in this case, I'm just going to graph whatever I get. So in this case, I end up with x is greater than 4, or x is less than negative 1. So negative 1, open circle, x is less than negative 1. Here's 4, open circle going greater than. So if I had to do this in interval notation, which I didn't say to do, but if I had to do this in interval notation, it would be negative infinity to negative 1, union 4 to infinity. All right, so let's take a look now. Let's just keep going. So I really don't like that this is negative. That bothers me. So what I'm going to do is I'm going to take all of this stuff and bring it over to the other side. And I don't have a lot of room, so I'm just going to show you. We're going to bring it over. So I get 0 on this side greater than or equal to x squared minus 4x minus 3. Now I factor. Let's go back and make this a minus, and we'll put this as a plus, because otherwise it doesn't factor. So it's x minus 1, x minus 3. So this gives me x equals 1, and this gives me x equals 3. So there's my two critical numbers, 1 and 3. It's greater than or equal to, so I'm going to put closed circles in. Now I got to decide, am I going to connect the dots or am I pointing in either direction? And again, I got to pick numbers. The easiest number to pick is 0. So if I plug in 0, the first one would be a negative 1, negative, and the second would be a negative 3. So that's a negative times a negative or positive. If I plug in a 2, so if I'm going to try x equals 2, the first one would be 2 minus 1, which would be positive. And the second one would be 2 minus 3, which would be negative. So in this area, it's negative. And then if I plug in, let's say 10. 10 minus 1 is 9, which is positive. And 10 minus 3 is 7, which is positive. So positive times positive is positive. So it's only negative in between these. Now, let's take a look to see what I want. Be careful. This is what I want now. I want... Now, this is hard to read, though. But do you read this? Do you see this? This says this side over here, is less than 0. Less than 0 means negative, which means I need to connect the dots. All right, isolate the weird thing. Get the weird thing alone. So you get negative 2, absolute value of x minus 3 is less than or equal to negative 4. Divide by negative 2, divide by negative 2, and I get x minus 3 is greater than or equal to positive 2. Now I'm going to set it up into two problems. Why did I switch it? Because you divided by a negative. So when you divide by a negative, you got to remember to switch the sign. By the way, did I tell you we're on day 7 or day 6? We're on day 6. This is exciting stuff. Yay! Day 6. X minus 3 is greater than or equal to 2. And if I finish this, gives me x is greater than or equal to 5. And then See, I don't know if I'm going to connect the dots or not, so I got to keep going. So then I get x minus 3 is less than or equal to negative 2. X minus 3 is less than. So I add 3 and I get x is less than or equal to positive 1. So there's 1, close circle. There's 5, close circle. Greater than 5, less than 3. Oh, and I forgot to do these in interval notation. So this one would be negative infinity to 1 union 5 to infinity. And this one here would just be bracket 1 comma 3. Whenever it's just to connect the dots, you just put the two numbers down and decide whether or not you're going to use parentheses or brackets. In this case, because it has the equal to, I use brackets. And I have a mistake here. I have a mistake here because this has got a solid circle. These and equal to, these should be brackets. So thank you very much, Bob. Thanks, Bob, for helping me out. Bob called me up and just told me it was live. It was crazy. So we just talked about how to graph these a few minutes ago, but let's just think about it algebraically. So I want to know the other critical number or the critical piece is what makes the denominator equal 0 or what makes the numerator equal to 0. Now this critical number would make this undefined and this critical number would make it equal to 0. So in the denominator, one of my critical numbers is 2. And in my numerator, my critical number is x equals, well, you have 4x minus 2 equals 0, or x is equal to 1/2. So those are my critical numbers. So 2, 1/2, and 2. So let's pick a number that's less than 1/2. Let's pick something like 0. So go back to the original problem. If I plug a 0 in here, the numerator becomes negative 2. The denominator is negative 2. And negative over negative is positive. So in this case, it's all positive out there. If I plug in 1, the numerator is 4 minus 2, which is 2, which is positive, over 1 minus 2, which is negative. Positive over negative is negative. And then if I plug in 10, the numerator is like 38, positive. And the denominator is 8, positive. So this is positive, 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 positive. And what do I want? I want where it's greater than 0 or where it's positive. Now, in this case, it's pretty simple. I'm just going to use two open circles. Going this way and going this way. Let me take a look and see what would happen. What would happen to this problem? Or how would this problem change if I said this, equal to? Would you fill both these circles in? Well, if I told you could only fill one of them in, do you know which ones you could fill in? The trick to it is, what would make this fraction undefined? X may not equal 2 because it causes the denominator to be undefined. So although we have an equal to, you can fill in the circles, you can only fill in this one. You cannot fill in this one because it would make it undefined. Now, if you remember correctly, when we did our asymptotes a couple days ago, one of our asymptotes is what makes the numerator equal to 0. And that would be okay, we're back. I'm sorry. Had a little brain fart for a second. So real quick, our vertical asymptotes, if you remember, are what makes the denominator equal to 0. So x equals positive 2. So, actually, I thought I had an easier way to draw these lines in. Apparently, I don't. Ding, 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 ding. So there's our vertical asymptote. Now, if you remember, also our horizontal asymptote is what makes the is a ratio of the leading coefficients. So in this case, it's, I can't even see that. Why am I doing that? It's 4 over 1. So if I look at this 4 over 1, that would be my horizontal asymptote. So if I draw my horizontal asymptote, which is y equals 4, And here. So what happens is at 1/2, which is what this is, it becomes negative, which we don't like. So anything less than 1/2, it's positive. And then anything greater than 2, anything on this side is greater than 2, and it's always up here in positive. So there's why that is the case. So anything between 1/2 and 2, that's between this point here and this line here, it's negative. All right, there we go. That's that one done. Let's go to the next one. All right, so in each case, state the solution set, and graph the solution set. So our only critical number here is 2. So as I look at my number line, I'm going to put the number 2 on here. And I got to know, do I go to the right or go to the left? Well, I want negative. So let's try 0 and let's try 10. By the way, open circle. I just don't know if I'm going left or right. If I plug in 0, I get 5 over 0. So this is positive 5 or positive divided by 0 minus 2. That's negative. Positive divided by negative is negative. So in this whole area, it'd be negative. Negative, 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 negative. If I plug in 10, I get 5 over 10 minus 2 is 8. So that's positive over positive. So if I go this direction, it's always positive. Since I want less than 0, I want this way. So my answer is x is less than 2. In interval notation, negative infinity to 2. Parenthesis. Don't I make any of these equal to? That was dumb. So I'm going to make this one equal to. Just to kind of make things a little trickier. So my two critical numbers are x equals negative 3. That's what makes the numerator equal to 0. And what, that's what makes the denominator equal to 0. And by the way, that's one of my restrictions on the domain is x can't equal negative 3. And my other one is x equals 5. What makes the fraction undefined? What makes the fraction equal to 0? So I'll plug those two critical numbers on my number line, negative 3 and 5. Now I need to determine whether or not I'm going between them or on the outside of them. So I'm going to try a number out in this direction, negative 10. I'm going to try 0, and I'm going to try positive 10. So when I plug negative 10 into the numerator, I get negative 10 minus 5, which is really negative, all over negative 10 plus 3, which is also negative. Negative divided by negative is positive. Now I'm going to try 0. 0 minus 5, that's negative, all over 0 plus 3, that's positive. Positive divided by negative is negative. And then if I try 10, 10 minus 5 is 5, which is positive. 10 plus 3 is 13, which is positive. So positive, 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 positive. Okay, so I want, first of all, I'm going to put open circles here because I'm going to decide whether or not I fill them in a minute. Normally with the equal to, I'm going to fill them in. But I want greater than 0. Greater than 0 means we're pointing off into either direction. Now, we said that the restriction on the domain was x cannot equal negative 3. So this circle cannot be filled in. However, because x can be 5, it's not restricted in the domain, I'll close that circle. So my answer is x is less than negative 3, or x is greater than or equal to 5. Or another way to write this in interval notation is negative infinity to negative 3, parenthesis, union, bracket, 5, comma, infinity. All right, we're getting close. We only got 4 left. So in order to figure out what your critical numbers are, in this case, we're going to have a couple of them. This is x minus 1, x minus 2. So x equals 1 and x equals 2 are my critical numbers. My other critical number is what makes the denominator equal to 0. And in this case, the denominator equal to 0 is x equals 3. So let's look at my number line. Actually, it's 1, 2, 3. Toes bother me. Okay, this is going to be tricky. Here's what we're going to try. First of all, I want where it's negative. And I'm going to put, and since it's not equal to, these are definitely going to be open circle. The only time you get into trouble, by the way, is when it's got an equal to part. And then you got to look to see when it's undefined. Like I'm going to put an equal to on this one. And we'll look at that in a second. So the first number I'm going to try is 0. So here's what I've got. And I'll remind you, this one was x minus 1, this one was x minus 2, and this one is x minus 3. So if I plug in 0, if I plug in the value 0, I want to try that. This would be 0 minus 1, that would be negative. This would be 0 minus 2, that would be negative. And this would be 0 minus 3, that would be negative. 3 negatives make a negative. So anything in this direction is negative. Now, to make things easier, I'm going to try 10. I'm going to try the number 10. It's way out here. 10, 10, and 10. 10 minus 1, positive. 10 minus 2, positive. 10 minus 3, positive. So everything out in this direction is, in fact, positive. Now comes the hard part, but I'm going to try to make it easier for you eventually. Now we're going to try the number 1.5. (1.5) minus 1 is positive. It's 1.5 minus 1, still positive. 1.5 minus 2 is negative. 1.5 minus 3 is also negative. 2 negatives make a positive. All right, now we're going to try the next number. I'm not going to go through it this slowly every time. You guys got to get a good handle on this. Now I'm going to try 2.5. So 2.5 minus 1, positive. 2.5 minus 2, positive. 2.5 minus 3 is negative. One negative makes a negative. So anytime you have an odd number of negatives, it's negative. Anybody notice anything about the signs? They flip back and forth, right? I want where it is less than 0 or negative. So first of all, we got to connect the dots or arrows. So I want a negative, so I'm going to go in this direction. And I want in between here. The other parts is positive. So answer, x is less than 1 or 2 is less than x is less than 3. That's one way to do it. You could also do it this way. Negative infinity to 1, parenthesis, union, parenthesis, 2, comma, 3, parenthesis. There's your answers. All right, let's take a look at this one. Let's factor this numerator first. I know the denominator is going to give me a number that's x equal to 1. It's also where it is undefined. That means if 1 is part of my answer, I cannot put a solid circle there. Even though I've now changed this to less than or equal to, I can't do that. Factoring is x minus 4, x plus 2. So my critical numbers here are x equals 4 and x equals negative 2. So I'm going to toss them on my number line. Negative 2, 1, and 4. Now, I'm going to go through and put solid circles on negative 2 because it's got less than or equal to, and 4. But I can't put them on 1 because it's in the denominator. So I'm going to use that as an open circle. All right, now I just got to decide. The easiest number to plug in is 0. So let me just remind what we got here. Parentheses, 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 parentheses. Now remember, in this one, I'm going to do this one last time. This is x minus 1. This is x minus 4. And this is x plus 2. So I plug in 0. This would be negative. This would be positive. and this would be negative. Two negatives make a positive, and since 0 is in between these two. Now, probably from there, I know this is negative, this is positive, and this is negative. But I still want to make sure. I want to make sure, because every once in a while that I'll throw you a trick, or I'll throw something different at you, or I'll just try to mess with you a little bit. So let's try a different number. Let's try negative 10. Negative 10 minus 4 is negative. Negative 10 minus or plus 2 is negative. And negative 10 minus 1 is negative. 3 negatives, or an odd number of negatives, is negative. So I'm definitely right here. This is right. So let's try 3. 3 minus 4 is negative. 3 plus 2 is positive. 3 minus 1 is positive. 1 negative is a negative, so I'm okay here. Now let's try 10. 10 minus 4 is positive. 10 plus 2 is positive. 10 minus 1 is positive, and I'm okay here. I want where it is less than or equal to 0. So I want where it's negative. So that's in this direction, or connect the dots here. So again, I can say x is less than or equal to negative 2, or 1 is less than x is less than or equal to 4. Be careful with the equal sign. Or I can say negative infinity, negative 2 bracket, union, parenthesis 1 comma 4, bracket. 2 left, kiddies. So here I tried to trick you a little bit. X equals 0 is one of my critical numbers. This one, if I factor it, I get x plus 3, x minus 3. So my critical numbers are x equals negative 3, x equals positive 3, and x equals 0. Negative 3, 0, and positive 3. And because this one looks kind of, the last one actually, I'll show you graphically what that one's going to look like. All right, so it does not have an equal to, so I'm going to put open circles on all three. Now, had it had an equal to, the only one I would have been able to put a filled in circle is this one, because it's undefined at these 2 points. All right, so we got a test. So if I plug in negative 10, this would be negative. Negative 10 plus 3 is negative. Negative 10 minus 3 is negative. 3 negatives make a negative. Odd number of negatives is negative. Now I want to plug in negative 2. Something in here. Negative 1. Negative 1, well, that's just negative 1. Negative 1 plus 3 is positive. Negative 1 minus 3 is negative. 2 negatives make a positive. Now I'm going to plug in 1. 1, well, that's just 1 is positive. And 1 plus 3 is positive. And 1 minus 3 is negative, so that's negative. And finally, I'm going to plug in 10. Remember, you're plugging in 10 here, so don't forget, you're plugging in, I plug in 10 here, that's just positive. I plug in 10 here, that's positive. And I plug in 10 here, that's positive. So positive, 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 everything is positive. So I want, again, take a look, I want where it's positive. I want this one, and I want this one. So let's connect the dots. Arrow in that direction. So my answer is negative 3 less than x less than 0, or x is greater than 3. And in interval notation, parenthesis, negative 3, 0, parenthesis, union, 0, 0, comma, infinity. All right, last one over here. Holy crap. This one looks tough. I'm going to change this to an equal to, by the way. So let's factor that denominator. That denominator looks like it's going to go 2x, 2x, minus 3, minus 3. Yep. So this is actually only, this is the same as 2x minus 3 squared. Right? Would you all agree that? 2x minus 3 squared. And what do I know about anything that's squared? Always positive. So in this case, my critical number is x equals 3 halves. So I have two critical numbers. I have 3 halves, which is like 1.5. It is 1.5. And 4. Because this one gives me x equals 4. So what I have on the denominator is, this is x minus 4, right? Sorry about that. That's a little embarrassing. So this is x minus 4. And in the denominator, I have something squared, which is really 2x minus 3. But I don't even care what this is. As long as it's not 0, I'm okay. Now, I'm going to put my circles on. Open circle and open circle. Now, but because this is equal to, I should be able to fill them in. I cannot fill in this one because it's undefined at 3/2, but I can fill in this one because I don't care about the numerator. I only care about the denominator. So now I got to decide, am I going to connect the dots or am I going to go in opposite directions? So let's see. This one might get tricky. Let's plug in 0. 0's over here. So 0 minus 4 is negative, and this is always going to be positive. So negative, 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 negative. Let's plug in 2. 2 minus 4 is negative. So this is negative, 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 negative. Let's plug in 10. 10 minus 4 is positive. The bottom's always positive, so this is positive, 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 positive. I want only where it's positive. So my answer is x is greater than or equal to 4. Or bracket 4, comma, infinity. Now, I apologize. I just realized that was all by my head. I'll move my head. I should have moved my head. You should not even have had that problem, because I will, when I do this at the end, I'll have moved my big fat head so you can actually see that math. Okay, but what I do want to see is, I do want to look at this graphically. So let me get out of this. And let me type this in. The numerator is x minus 4. X minus 4. And the denominator is 4x squared minus 12x plus 9. And wow, that looks weird. Wait, I don't want to do that because that gets... So what's going on here? Well, if you remember correctly, let me erase a lot of this. Okay, so if you remember correctly, what makes the denominator equal to 0 or x equals 3/2, that's a vertical asymptote at 3/2. So if I look at 3/2, oh look, at 1.5, it looks like I have a vertical asymptote right here. Yes? Now, come back. Where do I have a horizontal asymptote? Well, I have a horizontal asymptote at the ratio of these two things. Well, the ratio of those two things is 1/4. So if I'm looking at this thing graphically, at 1.5, I'm going to have a vertical asymptote, and at 1/4, so if this is 1, at 1/4, I'm going to have a horizontal asymptote. Sorry, that should be a dotted line. So let's go back and look at this thing graphically. At some point, it looks like it might come across the axes. It's hard to tell. So let's go menu, let's go trace, and let's go graph trace. We'll move this up here, and then go menu, trace, and then graph trace. So if I move to the left here, you'll notice that the x value is getting at 1.5, it's undefined. And if I go to the left more, notice it's coming back up. But at 1.5, it's undefined. So here at 1.8, 2, 2.4, still negative. Notice this is still negative right here, negative. 2.7, still negative. 3, still negative. 3.3, still negative. 3.6, still negative. Very small. 3.9, still negative. 4, it's now at a critical number. It's at 0. And notice what happens when I go to the right of 4. Now, I don't care how small it is. You notice it is still a positive number. And we said the asymptote was 1/4, right? 1/4 as a decimal is 0.25. Watch these numbers right here. We're going to get closer and closer to 0.25, but not go over. It's going to take a long time. Anyway, that's the answer. There we go. So, answer is greater than 4. And that's it. That's all she wrote. All right, now you learn how to graph or to work with the rational inequalities. All right, kids, that's it. Oh my God, that was so much fun. Day 6 is over. Day 7's coming up later. Goodbye, kids. Have a great day. Have fun storming the castle.